AI agents have transitioned into the core of enterprise infrastructure. They are now driving measurable operational returns across every major sector. 80% of organizations report measurable ROI today. And looking at the data, 57% are already deploying agents for multi-stage workflows. If we look across company sizes, startups, mid-market, and large enterprises, the adoption rates are almost identical. This is an industry-wide transition happening at every scale. But there is a massive trap waiting. Gartner projects that 40% of agentic projects will be canceled entirely by 2027. Teams spin up pilots that work perfectly in a demo, but completely fail when they hit real-world edge cases, compliance reviews, and tracing requirements. Success in these high-stakes deployments depends on the architectural framework established on day one. The underlying AI model is often less critical than the governance and tracing built around it. To make the right architectural choice, we have to clarify what we are actually building. We need to distinguish an AI chatbot from a true AI agent. Chatbots rely on pattern matching. They check a limited, static knowledge base and follow predefined rules to answer contained questions, like returning a shipping policy or helping you reset a password. Agents do the work. They interpret nuanced instructions, break down multi-step plans, manage state across systems, and use external tools, all without human handholding. If you try to solve a complex multi-stage workflow problem with a chatbot architecture, the system will break the second it encounters an unexpected variable. Accurately diagnosing your business problem dictates the level of cognitive architecture you need. You must map the tech to the task before writing a single line of code. IBM maps out a clear taxonomy to help match task complexity to the correct baseline architecture, starting with the most basic implementations. The simplest forms are reflex agents, both simple and model-based. They operate purely on direct responses to environmental triggers and basic internal models of the world. These agents follow rigid condition action rules. If X happens, execute Y. This makes them highly effective for predictable, contained processes, like basic IT routing. You get highly predictable, low-cost execution, but they are entirely brittle. If the environment changes or a query falls outside their programmed bounds, they fail immediately. For dynamic environments, you need goal-based or utility agents. These systems evaluate multiple possible outcomes, balance trade-offs, and use reasoning to achieve complex, multi-step objectives. Once you decide you need that advanced reasoning power, you enter the framework layer. And the developer framework you choose here determines whether your system survives production. Let's compare the two dominant approaches to multi-agent architecture. First, the fast mover approach, role-based frameworks like Crew AI. Crew AI lets you define specific personas, goals, and backstories. You are essentially assembling a team of specialists. This allows developers to spin up collaborative, multi-agent prototypes in a matter of hours. But that speed costs you structure. These rigid role assignments lack deterministic execution paths. When you need to tweak behaviors mid-project or debug a routing delay, you end up fighting the framework. On the other end of the spectrum is the enterprise standard for absolute control and auditability, graph-based frameworks, specifically LangGraph. LangGraph models workflows as directed graphs. You know exactly what happens at every step, and it uses save-state memory checkpoints that actually let you time-travel debug through an execution history. The trade-off here is friction. LangGraph demands massive upfront architectural design and presents a steep learning curve for development teams. The rule is straightforward. Pick Crew AI if you need a working MVP by Friday. Pick LangGraph if your system has to survive strict compliance audits and 2 a.m. failures. Sometimes the orchestration isn't your biggest problem. Sometimes your primary bottleneck is data retrieval. If your agents spend all their time reasoning over large, complex knowledge bases, Llama Index is the dominant orchestration layer for heavy retrieval-augmented generation. It is best in class for document reasoning and enterprise search, but it is less optimized for coordinating complex, autonomous tool calling actions. Alternatively, your team might already be deeply committed to a specific ecosystem. In that case, provider-native SDKs from OpenAI or Anthropic offer the path of least resistance. Anthropic's Claude Agent SDK is particularly notable for its deep Model Context Protocol, or MCP, integration. This architecture securely connects an enclosed, sandboxed agent directly to external databases and tools. These SDKs offer the lowest friction to production and come with sensible safety guardrails built in. The cost is high vendor lock-in. You're tying your architecture tightly to one provider. Often, an organization's existing data gravity and ecosystem commitments will dictate their agent framework before development even begins. Before making a choice, verify you actually need a framework. If you just have a single agent calling one tool, raw API calls with structured outputs will be cheaper, faster, and much easier to maintain. If you do need a framework, we can map 3 distinct organizational profiles to their optimal 2026 architectures. An agile startup should default to CrewAI or the OpenAI SDK for fast MVP validation. You gain speed, but you accept the risk that you may have to rebuild from scratch when you scale. A regulated enterprise requires LangGraph and Langsmith for total auditability. You get strict control, but you must absorb the risk of heavy long-term LLM consumption and maintenance overhead. And a legacy data integrator operating on traditional enterprise software should choose Semantic Kernel. It integrates perfectly with existing C# and .NET environments, though you sacrifice the momentum of the open-source Python ecosystem. Remember the 40% cancellation rate Gartner warned about. Projects fail when teams pick a framework that fights their operational reality. The best framework isn't the one with the most hype. It's the one that minimizes future regret. Evaluate your constraints, accept your specific trade-offs, and start building.
Thank you for watching. For more professional AI insights, remember to like this video and subscribe to AI Corecast.